Okay, welcome to Social Science Research Methods Week 3. Today we are going to learn to describe social statistics using measures of central tendency. Um, when we talk about measures of central tendency, we're talking about mode, median, and mean. And hopefully those concepts feel a little bit familiar to you from Stat 141Q. Really, what we mean when we talk about those measures is ways to reduce the data down from raw scores, so each individual response from each individual respondent, into aggregated data that we can um, look for patterns among. But before we do that, we have to learn how to read frequency tables. A frequency table lays out a variable, its categories, and the number of responses. So in this example, I have pulled a variable from the 2006 General Social Survey, prisoners under the sentence of death by region, Northeast, Midwest, South, and West. Frequency is denoted by lowercase f, and it is literally the number of responses in a given category. So, how many prisoners are under sentence of death in the Midwest? How many prisoners are under sentence of death in the Northeast? We're literally just counting up the responses. So, frequency is really about addition. You'll see here in this frequency table, we also have a total number of cases. So that's the total number of prisoners in the United States under sentence of death. It's not noted here, but generally in frequency tables, total number of cases is denoted using a capital N. Okay, we can expand out a frequency table to also show us the proportion and the percent. Proportion is literally just the frequency in a given category divided by the total number of cases. So if frequency is addition, proportion is division. Percentage then is taking that proportional value and multiplying it by 100 so that you can say something about the percentage in this case of prisoners under sentence of death by region. We can also have comparative frequency tables. So here I've picked a variable about type of criminal offense in a given regional area, and I'm comparing city A and city B. You can see here that the percentage of robberies in city B is higher than in city A, but the percentage of assaults in city A is higher than in city B. You may want to use this data to do things like decide where to buy a home or decide where to rent a home or where to open a store or where to send your children to school. And this is the kind of data that you would want to look at to make those decisions. Okay, if we have a frequency table that gives us the frequency in each category and the total number of cases, then we can also calculate two other types of percent. So we talked about proportion and percent. We also have two other kinds of percent, valid percent and cumulative percent. The difference between this quote unquote regular percent and valid percent is the difference between the total number of cases in a particular variable. And let's stop here and talk about cases for a second. When you're writing surveys as a social science researcher, each question is in its own way a variable. And each variable then needs to have a number of categories for the respondent to answer. Our job is to make sure that those categorical options are exhaustive for the participant. You don't want to write surveys where participants frequently feel like there aren't answers that sort of speak to their personal truth, because the likelihood is that they may not answer those questions. Now, we put all of this work into writing our questions in a very sort of exhaustive way, but we also have to come to the project with an assumption that some people will not answer all of the questions in your survey. And how do you handle that? What we do is we write in options for not wanting to answer the question. So beyond the regular categories in the variable, you would also add maybe an answer that says, I don't know, not applicable, or I prefer not to answer. And that is a way for us to aggregate those participants who chose not to answer the question and get them out of the data as we attempt to look for patterns and describe the statistics that we have. Even with those categories, some participants may simply choose not to answer the question at all. And those get put together with these sort of pre-created um, don't want to answer categories, and together we refer to them as missing values. And generally, when we're doing social science research, we don't care about the missing values, unless there are a lot, in which case it's probably telling you something about your survey. But we don't want those values messing with our calculations of things like mean, median, and mode, those measures of central tendency. And so what we do is we get rid of them. So you can calculate percent and cumulative percent and valid percent in a way that makes more intuitive sense. So when we talk about the difference between percent and valid percent, what we're talking about is the difference between dividing the frequency by the total number of people who took the survey, or the total number of people who answered the question in the categories that are directly reflective of the question, not the missing categories. We generally care more about valid percent than regular percent when we're doing these sorts of calculations. So to calculate valid percent, you would divide the frequency by the total number of cases minus those missing cases. Okay, you can see here I have pulled a variable from the General Social Survey 2006, number of children a respondent has. To calculate the valid percent, to calculate the cumulative percent, you would take the valid percent of the category above it. And cumulative percent then allows you to say something not just about one category, but about all of the preceding categories. So in this example, you'll see the first line of the frequency table, the valid percent and the cumulative percent are the same thing. And that's because there's no valid percent ahead of that first line of the frequency table to add to the existing cumulative percent. So valid percent, cumulative percent, same thing in the first line. In the second line, the valid percent for the second line is added to the cumulative percent in the first line of the frequency table to create a cumulative percent for the second category in the frequency table. And then that cumulative percent tells you not just about that category, but about the preceding category. So you can see here in the example, I've started to fill this frequency table out for you and calculate the cumulative percent that almost 70% of respondents have 2 or fewer children. So it's telling us something about the category 2 children and the categories 1 child and 0 children. All right. I would suggest that you pause here and take a few moments to try to fill out the rest of this frequency table. I'll give you a second. Okay, I hope that you found that relatively easy. If not, make a note of where you had some difficulty and bring those questions to discussion on Thursday. Okay, central tendency lets us use frequency to describe typical cases in a data set. And that's where mode, median, mean, and range come back in. We're going to start with mode and median because those are the simplest of the measures of central tendency. So mode is the most frequent. It is the category that has the highest frequency. That is your modal category. Simple. The median is a little bit more complicated. It divides a data set in half. It is the middle value. If you're dealing with an even number set of values, which means there isn't a middle value, you take the two middle values, add them up, and divide them by 2 to get a midpoint. We call that the midpoint value. Also, relatively simple. Okay, let's move on to mean. Mean is just the arithmetic average. But when we're calculating mean in social statistics, we have to distinguish between grouped data versus ungrouped data. We're going to start with ungrouped data because it's a little bit easier to deal with. When we're talking about ungrouped data, we're talking about raw scores. So in this example, I have given you 6 quiz scores out of 10. We can say these are your quiz scores, even though we're not going to do any quizzes this semester. Each y sub I, y sub 1, down to y sub 6 has a particular value. That is the quiz score out of 10. So to calculate a mean, we would use the equation y bar equals the summation of y sub I divided by n. Now let's break that down. Mean is always notated by y bar. That's that line above the capital Y. Equals the summation, that is that sort of E looking symbol, of the total number of cases, that's the uppercase N that is above, denoted above the summation, and starting with the first value, y sub 1. That's what I equals 1 means. So we're calculating all the values starting with the first value. We're adding all of those up and then we're dividing them by n. So here you see each of those values will be added and then we divide them by 6 because that is the total number of cases here. That's our n. Okay, that's relatively simple. Let's move on to mean for groups data because most of the data that we're going to work with in this class and most of the data that you'll work with as a social scientist will be groups data. Even if you have your own raw data from surveys that you've given or you're looking at scores or whatever it is that you're analyzing, the likelihood is that you're going to take that raw data and input it into a program in a variable format, in which case it becomes groups data and it requires a different kind of equation. So here's our groups data equation. We still have y bar because that's always mean, no matter if you're talking about groups data or not. Equals, we start with the summation again in this formula. Here though, you'll see a K instead of an N above the summation. That K is notating the number of categories in a particular variable. And again, in the denotation below, the summation I equals 1 means we're starting with the first category. Here, when you're dealing with groups data, you multiply the frequency in each category by the categorical value. That's what that y sub I turns into when we're dealing with groups data. And then we divide that total number by n. So here's an example. I pulled this variable from the General Social Survey 2008 data. It is the variable sex frequency. How often in the past year have you had sex? Now, what you'll see here is that this is an ordinal variable, variable, but it's not an interval ratio variable. That means that it is ordered in its categories, but not explicitly numerical. You'll notice from from the formula that I showed you a minute ago, though, that you need a number, one number as your y sub I for each category. And so before we can start to calculate the mean, we have to recode our variable categories to create that singular number that we can use in our calculation. So how are we going to do that? It's relatively simple. We're going to take the direction that the categories have already given us and intuitively turn those into numbers. So for not at all, that's 0. Once or twice, we pick the higher ordered always when we're doing this kind of recoding work. So we would pick 2. 2 to 3 times, you'd pick 3. Monthly, that's 12, right? Because there's 12 months in a year. Weekly, that's 52 because there are 52 weeks in a year, and so on and so forth. Once we have calculated a specific y sub I for every category in the variable, we multiply the frequency in each category by that categorical value, that y sub I. Then we add all of those numbers up, because we're going to do that for each category, and divide it by our total number of cases. Generally, if you are given the choice between total number of cases with the missing or without the missing, you want to take the total number of cases without the missing. Okay, you can see that this is all done here for you, so you can see the calculation process of calculating the mean in this example. But surprise, I have another example for you. So let's look at this. Here I have given you the variable age of respondents, except the categories are not singular individual ages, they're age ranges, 20 to 29, 30 to 39, 40 to 49. So again, we don't have a single number for our y sub I. How do we calculate that? Well, we go back to the median calculation where we talked about calculating a midpoint and do that work here. So we take the highest number in the range, the lowest number in the range, we add them together, and then we divide them by 2. And that gives us a midpoint value for each category. And that midpoint value becomes our y sub I. So for each category, you multiply the frequency by the midpoint value, add all of those numbers up, divide them by n, and you will have your mean for this variable. Pause here and spend a few minutes trying to calculate the mean on your own. I'll give you a second. Okay, again, I hope that you were able to calculate that relatively simply, but if you had any trouble, make a note of it and we'll talk about it in class. The last way to calculate a mean of a variable is dichotomous variables. When we talk about dichotomous variables, we simply mean 2 categories. Dichotomy means 2 categories. Oftentimes in social science research, those 2 categories are yes, no. They could also be sort of rigid gender or sex variables where you're just looking at male, female, or man, woman. In order to calculate the mean, the y sub I becomes 0 or 1, because generally when you're dealing with dichotomous variables, they are nominal in type, which means they can't be turned into numbers on their own. However, because we're doing math, we need numbers. So one category you designate as 0, the other category you designated as 1. Now, if we go back and we look at our formula for mean for y bar, we again see the frequency times the categorical value. Well, then the frequency gets times by 0 for the first category and multiplied by 1 for the second category. We know that when we multiply something by 0, it becomes 0. And when we multiply something by 1, it stays the same. And so the mean of a dichotomous variable is always the frequency of the category you've designated as 1 divided by the total number of cases. It's simply a proportion. That was a lot. So we're going to stop there. I hope that you feel like you have a little bit of a handle on how to use measures of central tendency to describe social statistics. Next week, we're going to talk about how to infer data from social statistics using measures of dispersion. I'll see you then.